Hey there, AP Stats kids. Today we'll be doing a quick review over Chapter 4. The best way for you guys to take in these videos would be to pause it, look at the question, and then try it yourself, and then I'll go over what the answer is. So again, I'm expecting you pause it, read it, and then I'll go over it. It'll save us all some time. So let's take a look at number 1. This is from section 4.1. So, may if you guys can read it. So, does this represent the opinions of all Los Angeles residents? Explain. No, it doesn't. It does not. This is voluntary response, right? You can only draw a conclusion based on the people who agreed to do it. There was no random sample. There's no random selection in this. So voluntary response bias, no, you can't use it. All right, number 2. I guess I should count down, like, spoiler alert on these. I'm letting you read it. I hope you pause and read it. All right. Answer coming in 3, 2, 1. All right. How do you find a simple random sample of the 88 rooms? Well, you could have done this a lot of different ways. I would have said I'm going to number all the rooms from 1 to 88. And then I'm going to use a random number generator and randomly select the 2 digits in a row until I get... I'm going to use number of the rooms from 0 to 880 and use a random number generator to randomly select 88 numbers. And if there's any repeats, I just discard that and grab another one. And boom. That's all there is to this one. Alright? I will write eventually, I promise. Maybe. I don't know. Let's look at B. Again, B is pertaining to this up here. So read this again. Maybe jot down the question. Explain how to select a stratified sample of the 88 rooms. Sorry guys, my mic's kind of broken, so I'm all over the place. So again, pause it, try it. Answer's coming in 3, 2, 1. Alright, for this one, you're actually going to have 8 different rooms. You're going to have the South Tower room facing the beach. And you're going to need to select 20 of those people. You're going to need 20 people in the South Tower facing the street. You're going to need 20 people in the North Tower facing the beach. You're going to need 20 people in the South Tower, facing the street. And then I'm going to do 2 people. Oh, that should have been the north. I'm going to need 2 people. All of these are going to be the same. But each one's going to be a suite. So you're going to need 2 from a suite. So you're going to need 2 people from the South Tower suite. 2 people facing the beach. 2 people from a South Tower facing street in a suite. Okay. Now, if I were to cluster sample this like in C, why would just picking 2 floors not be a good way to do it? Answer's coming in 3, 2, 1. The reason why just picking 2 floors wouldn't be a good idea is because each floor is going to have very homogeneous rooms. homogenous. And if they're homogeneous rooms, each floor does not represent all the floors. You don't get a good sample that way. You don't get a good variety. You don't get a little bit of everything that way. So you'd have to just do a simple random sample of the rooms. All right? All right, let's look at... Whoa, my writing. Wowie. All right, which of the following sources of sampling error are sources of non-sampling error? Explain your answers. Pause it. Try all three of these. Answers are coming in 3, 2, 1. All right, so for 3A, the sample lies about past drug use. Well, did you make an error in sampling? No. So that's a no, because they lied. That's a response error, right? So not your fault. That's a non-sampling, because that's a response. Again, you could have sampled correctly, but they lied. What about someone makes a typing error recording that data? Did you make a mistake sampling? No, that's a non-sampling error. That's actually called a processing error. What about data gathered by people who have to mail in a coupon printed in a newspaper? Is that a sampling error? Yeah, that's a sampling error. Because you aren't making a good sample. You're looking for a voluntary response. And that's not a simple random sample, and that's no bueno. Alright, again, we're going to pause it. You read it, you try it. Answers coming. 3. I gotta get this microphone fixed. It's driving me nuts. Oh, nope. It's not happening. It's just not happening, guys. Alright. Let's look at these lice people. Or be a nice person, not a lice person, you know what I'm saying? Alright, so what are the experimental units in this? It's going to be households, not people. Because they selected households. Why are you doing this, Epic Pen? What's my explanatory value? The different meds, right? Because I think they're going to have, they're going to change the amount of our response variable, which is lice. Who has it, who doesn't, right? And the treatments were the 2 different drugs, invert and derp and derp. So inverpaderp and mertaderp. All right, good. I'm such a good teacher. So good. This fertilizer. Hopefully, all paused it, read the question. Feel like a broken record if a record was the thing. So, what's our explanatory variable? So, what do we think is causing an effect? Well, we think different fertilizer and water is causing an effect. Causing an effect on what? The weight of those tomatoes. Weight of tomatoes. Matos? Tomatoes? Alright, what are our experimental units? Our experimental units are the tomato plants. That's what we're actually testing on, right? Right? And list all the treatments. There's actually going to be 6. Alright, because we're going to have fertilizer, and each one's going to be in different categories. We're going to have 0.5, 1, and 1.5 gallons of water, right? Aqua. And then we'll have the non-fert, the nernfert, the non-fert, and then we'll have each of those in 3 groups. So we'll have 6 groups, 0.5, 1, and 1.5. Alright. Oh, I didn't. Oh, answer's coming. Guys, watch out. Alright, so again, pause and read it. Answer's coming in 3, 2, 1. Alright, so you have a class of 30 kids who volunteer. How would I assign 15 of them? Well, you could put numbers in a hat. You could put slips in a hat to say caffeine or non-caffeine, and they randomly draw them. You could do a spinner. You could use a simple random number generator and assign numbers 1 through 30 to each student, and then randomly select 15 numbers for one of the 2 treatments. Many different ways. All right. Number 4. Read it. Let's try it. Answers coming in 3, 2, 1. All right. Okay. Oh my gosh. All my kids are up from their nap. We have to hurry. We have to hurry. So I gotta pause this. All right, y'all. Time is of the essence. My wife's at work and my kids are all awake, and I got them busy for the next 3 minutes. So why is a randomized block design not preferable to a complete, or why would a randomized block be better than a completely random? Well, if I randomly selected 100 people for each group, there's a chance that the 100 people got A were all bad texters, and the 100 people for B were good texters. So we would not get accurate results then. The big thing why we'd use a block design is to remove out a variable, right? If we separate them into groups of frequent and non-frequent texters, then we'll know for sure if type A is faster for both novice and non-experienced and experienced texters, then we know A is better. So here's how we would do the block design. We would take the 300 people for B, this is B. We'd separate them into frequent and non-frequent texters, so expert and novice texters. Then we would randomly assign, you have to write random assigned, into the two groups. So the frequent texters, we'd randomly assign into groups of 50 for A and 50 for B. And then we would compare means of those. Then we take our non-frequent texters and separate them into two groups, 100 for A, 100 for B, and then we'd compare means. All right, guys. I don't even know if this was helpful. I hope it was. Have a great day.